In this video, we are going to be looking at the urea cycle. Notice that the word urea cycle is a combination of two words, which is the urea and then the cycle. The word urea is simply a chemical compound found in the urine of the mammals. It's simply a waste product formed in a liver when proteins are broken down. And notice that the body gets rid of the urea through the kidney. And what about the cycle? This simply refers to a series of events that happens repeatedly in the liver. So when we put the two words together, urea and then the cycle, it simply refers to the process in the body that transforms harmful ammonia into harmless urea for excretion. One important thing which you need to keep in mind is that the urea, let's put it as U, has a molecular formula of 1 carbon, 4 hydrogen, 2 nitrogen, and 1 oxygen. And the ammonia, A, it has a molecular formula of 1 nitrogen and 3 hydrogen positive. Also notice that the urea is comparatively non-toxic and can easily be excreted in the body by the urine. Since we said the urea cycle takes place in the liver, notice that on the liver cells, it takes place in two places, which is the cytoplasm and the mitochondria. Notice that in the cytoplasm, there is a formation of arginine isosonate. Let's say formation of arginine isosonate, and there is also formation of arginine. Let's put it this way, formation of arginine. And there is also formation of urea. Formation of urea actually happens in the cytoplasm. While in the mitochondria, there is only two formations, which is the formation of a carbonyl phosphate and the formation of sterolin. We said formation of carbonyl phosphate and the formation of sterolin. Let's take it once more. We said in the mitochondria, there are two formations, which is the formation of carbonyl phosphate and the formation of sterolin. And moving to the cytoplasm, we have three formations, which is the formation of arginine isosonate and the formation of arginine and the formation of urea, which is the last one. On the liver cells, the cycle actually begins with mitochondria, where ammonia combines with carbon dioxide to form carbonyl phosphate. This simply means inside the mitochondria, the ammonia, which is 1 nitrogen with 3 hydrogen, actually combines together with carbon dioxide. And if these two combines with carbon dioxide, they are going to form what we call the carbonyl phosphate. Another important thing at this point is that this free reaction requires 2 ATP, let's say 2 ATP molecules, and this, it requires the help of enzymes which we call the carbonyl phosphate synthesis 1. So at this point, the carbonyl phosphate, which is this, will actually react, and it's going to react with ornithine, and when it reacts with ornithine, it's simply going to give rise to what we call the sterolin. At this point, the sterolin will move back into the cytoplasm and combine together with what we call the aspartate. And notice that the aspartate is an amino acid. At this point, when the citrulline combine itself with the aspartate, what will happen? These two couples are going to give rise to arginine isosonate. In this case, the arginine isosonate will move further. When it moves further, it's simply going to split When it splits, it's going to form what we call the arginine and fumarate. The arginine is simply going to move further, and it's also going to divide into two. It's going to divide into what we call the ornithine and the urea. At this point, notice that the urea is simply going to excrete. It's going to be excreted. It's going to be excreted. When the urea is excreted, what then will happen to the ornithine? Notice that the ornithine will return into the mitochondria. When it moves into the mitochondria, it's simply going to continue the process, which is the cycle. So, this is it for this problem. I hope you find it helpful. If you like, feel free to do me a favor by clicking on the subscribe button. Thank you, and see you next time. In this video,